All right, today we are going to try and find how to find the volume and the surface area of a cylindrical prism. Basically, we're just talking a cylinder. So remember yesterday we found the volume and surface area of a rectangular prism, which was like a box. Today we're finding a cylindrical prism or a cylinder like this. I'm going to try and talk more normal so I get rid of the static as you guys are used to, which I'm trying to not do. And I'm also doing this as my kids are eating dinner. So if you happen to hear some noises in the background, you can listen for them. That would be my boys. Now, on this page, we're going to find the volume. Let's review what we did yesterday. I'm going to just kind of zoom out here a little bit. Put that on 75%. Yesterday, we found the volume of a rectangular prism. Would you all agree, as we find the volume, yesterday was length times width times height. But what if we did the length times the width, which you might all agree would be 12. I don't know if you can see that in there, but I tried to get that 12 to highlight in there. But 3 times 4 would be 12. And that 12 would be the area of what we would call a base. So that base. Then we take that base of 12 and we multiply it by the height of 10. And as you can see, the numbers grow up here. We get all the way to the top. And 12 times 10 is 120. So basically, if we wanted to change our formula from yesterday from length times width times height, we could just do the length times the width, which equals the base, and we go base times height. So volume on that would be base times height, where base, again, is the area of this base, in that case 12. So base times height. You might notice it's a capital B for base, and the capital B means the area of the base times the height. Hopefully that makes sense. Now, we can apply this. Yesterday we did a rectangular prism. Today, watch it, here it's going to change. Today we are going to do a cylinder. Now, a cylinder is the same thing then as a rectangular prism for finding the volume. It's the base times the height. The only difference here is the base of this. The base of this is not a square or a rectangle. The base of this one, as I move this up into place, is a circle. Well, in order to find the area of the base or the area of the circle, we need to remember our formula for area of a circle, which is pi times the radius squared. You should notice that the radius here is 5 inches. And pi, you should remember, is the same as 3.14. So in order to find the area of the circle, we take 3.14, which is the same as pi. We multiply that by the 5 inches squared, and we get a grand total of 78.5. So the area of the base down here, this is just the base so far. The area of the base is 78.5. Now we need to take that 78.5 and we need to multiply that by the height to get the volume of the entire thing. You'll see me moving this up and down. We want to get the volume of this whole thing, so we have to multiply the area of the base, the 78.5, and multiply that by the height, which there it is, 14 inches, to get our volume. As we do that, we find that the volume, again, which is your base times your height, area of the base times height, 78.5 times 14, the entire volume comes out to 1,099. You know what I forgot to put on here? That would be inches cubed. So it should be 1,099 inches cubed. So let's just recap this one more time, because I think the volume is a little confusing here. We need to find the area of the base, which in this case is this red circle. Since it's got a radius of 5 inches, we go 5 squared, which is 25, and we multiply that by 3.14, and we get this total over here of 78.5. We then take that 78.5, we multiply it by the height, which is right here, of 14 inches, and 78.5 times 14, which is right there, equals our grand total of 1,099 inches cubed. Now, that's how we find the volume. And today's lesson's a little confusing. It's going to take good notes on your part. So Mr. Anderson will probably pause this right now to give you a chance to catch up on your notes. Excellent. Now you are done taking notes on this. Now we're going to move on from finding volume to finding the surface area. So we'll move on to the next one. Define the surface area. Now, it might make sense. Look at any kind of can or cylinder. You might notice on that can or cylinder, to find the surface area, you have a base on the bottom, which is a circle. You've got a base on the top, which is a circle. And then if we take the rest of the can, which isn't the top or the bottom, and we cut it straight down and unfold it, it would make a rectangle like the blue rectangle listed below. I'll get back to that in a moment. In order to find the surface area then, we need to find the surface area of three things. We need the area of the top circle right up here. I'm starting to move it. As I slide that over, you can remember the area of a circle, which is pi times radius squared. We just did that on the last page. And if you remember, we did this on the last page. We filled in the numbers for this, and the area of that came out to be 78.5. So since I have two circles, and they both have an area of 78.5, we're going to have to add both of those together. But that's not all. We also need to add the area of the main can. Remember, if we cut that can straight down, cut a line straight down, and unfold it, it would make a rectangle. Now, that rectangle would have a height of 14 inches as seen on the lower rectangle here. But in addition to that, the length along the edge would be the circumference. Think about it. As I click this part right there, you can see in that yellow circle, the length of that rectangle would be the distance around. Pretend that I cut it right where that black 5-inch line cuts into it, and I cut that straight around. The distance would be all the way around that yellow circle for the circumference. Now, how do you find the circumference of a circle again? Well, I've got that formula for you. Circumference equals pi times the diameter. Remember, diameter is always twice as long as the radius. So if the radius was 5 inches, as our example above is, then the diameter would be twice that, or 10 inches. So we take pi, 3.14, times 10, and we get 31.4 inches for the circumference. Okay, that's this part right up here, 31.4. Now we know that the height of the rectangle is 14 inches. We know that the circumference or the top edge is 31.4 inches. To find the area of a rectangle, sorry, but my son Gavin is laughing at me right now. He's getting bored with this, as probably many of you are. The area of this is 31.4 times 14, or 439.6 inches. Gavin, we're almost done, so if you can be quiet for a little bit. Now, we need to take all three sides. We've got the area of these two circles, and both circles are 78.5. And we take the 78.5s, both of those. We take the area of the rectangle of 439.6. We add all three together to get the total surface area of 596.6 inches squared. Now, Mr. Anderson's going to give you a few moments here to write down the notes and ask questions on this. Wonderful. Now that you've done surface area, now that you've done volume, now we need to give you a chance to do it on your own. So, the next page here. Find the volume and the surface area of this one right here. Mr. Anderson can take questions. Why don't you come and see him as you have questions? And when you get that, bring those questions up to Mr. Anderson. He's going to pause this again until he feels you're ready. Great. Now that you've all got this, you should have an answer with a volume of 226.08 cubic centimeters and a surface area of the top circle 28.6, the bottom circle 28.6, and the can itself, which unfolded, would be 150.72. Add those three together, you get 207.24. All right, now you can get going on your in-class assignment. Good luck to you.